Welcome to a video on determining the domain of a function. Consider the following examples. On letter A, we are given a radical function of an even index. Recall from the previous video that to determine the domain of a radical function with an even index, the radicand must not be negative. And so we would take the radicand and set it greater than or equal to 0, which means that it cannot be negative. Solving for x, we can add x to both sides. So this statement says x is less than or equal to 7. Now we sketch a number line to represent this set. Suppose this number line represents x, and the number 7 is here. To be less than 7 or equal to 7, it means that the input values must be any number from -infinity to 7. And hence, in interval notation, the domain of this function is the set of all values of x from -infinity to 7, inclusive of 7. Now let's consider part B of the problem. Here we have a quadratic function. So on this function, there is no value of x that will ever make it undefined. And therefore, the domain of this function is the set of all real numbers. In interval notation, that would be from -infinity to +infinity. For letter C of the problem, notice here we have a rational function. Again, from our previous video, we know that division by 0 is undefined, and therefore the domain of this function is a set of all real numbers for which the denominator is not equal to 0. So let's go ahead and find those values that need to be excluded. Take the denominator and set it equal to 0 and solve. Since it's a quadratic function that can be factored, let's use the factoring technique to solve. So I'm thinking of two numbers that multiply to -5 and sum to +4. That would be +5 and a -1. So this is a guess and check method on factoring quadratic functions. You can read more about it in one of the review worksheets. Now that the equation is in factor form, the next step is to set each factor to 0 and solve. So solving for the first linear statement there, this gives us the answer of -5. And for the second one, x is equal to 1. These are the two numbers that will make the denominator 0. So we want to exclude these values. Hence, the domain of this function is the set of all real numbers except for -5 and 1. Let's indicate this set on a number line. So we want to exclude -5 and 1. We want all the values to the left of -5, all the numbers in between -5 and 1, and all the numbers to the right of 1. And so in interval notation, it's a set of -infinity to -5, union our next subset, which is between -5 and 1, and then union our last subset, which is from 1 to infinity. So this is the domain of h of x. For letter D, notice that we have a rational function, but within that rational function, we have a radical expression of an even index. So there are two things we want to consider. One is the values that will make the denominator 0, which we need to exclude. And number two, the radicand of the square root cannot be negative. So we start with excluding the values that will make the denominator 0. So solving for the 0 of the denominator, we're going to take that expression, set it equal to 0. We're going to add x to both sides. So this tells us that we need to exclude the value 6 from the set of all real numbers at this point. Now we're going to take the radicand. We know that it cannot be negative, so non-negative means greater than or equal to 0. Solving for x, this says that x has to be greater than or equal to -6. Let's sketch this out on the number line. So here we have -6. We also have a +6 based on our first statement, which says that we need to exclude 6. We're going to go ahead and indicate an open circle on that value. And then on our second statement, which is an inequality, x is greater than or equal to -6. So at -6, we want to include that value. We want all the numbers to the right of it. Now, once we reach the value 6, remember we need to exclude that. So there's a hole on our number line. And so in interval notation, the domain of this function is a set from -6 to 6, inclusive of -6, but exclusive of +6. And then the union for that gap, and then from 6 to +infinity. So this is domain of the function defined in part B. Finally, for letter E of the problem, we have a rational function that involves an absolute value. The only issue with this function is that our denominator cannot be 0. So we're going to take that expression and set it equal to 0. The solution to this equation need to be excluded from the set of all real numbers. So solving this absolute value equation, remember that the first step is to isolate the absolute value term. So one way to do that is to add the absolute value of a plus 2 to both sides, resulting in the number 8 on the left and the absolute value of a minus 2 on the right. Now we're going to interpret this statement. This means that a minus 2 is exactly 8 units from 0. So to be 8 units from 0, it means that a minus 2 is equal to 8, or a minus 2 is equal to -8. So again, using the number line to interpret this, we always compare distance to the origin. So to be 8 units from 0, there are 2 places or 2 numbers on the number line that are precisely 8 units away from the origin. And hence, taking the absolute value expression, setting it equal to -8 and +8. So we have 2 linear equations to solve for. For the first one, we're going to add 2 to both sides, making that a 10. And for the second one, we're going to do the same, add 2 to both sides, making a value -6. But remember, this is what makes the denominator 0, and therefore we need to exclude these values from the set of real numbers. So the domain of the function is a set of all numbers between -infinity to -6, union -6 to 10. We don't want those values. And from 10 to infinity. Again, using open parentheses on the interval notation to indicate that we do not want to include -6 nor 10.